6 circles. First problem. Sides of some triangles are given below. Determine which of them are right triangles. In case of a right angle, write the length of its hypotenuse. So now you can see there are four problems given totally in this first bit. So you're having 7 centimeters, 24 centimeters and 25 centimeters. We have to prove whether it forms a right angle triangle or not. So we'll take always the bigger side, whatever is the largest value in this, that is 25, we take it as the hypotenuse. We have to see that the other two values which are given, if we square those and add them, it should be equal to the square of the hypotenuse or square of that larger number. Then it is said to be a right angle triangle. According to Pythagoras theorem, we have that the square of the hypotenuse is equal to sum of squares of the other two sides of the triangle. So here you can take it as 7 centimeters, 24 centimeters, 25 centimeters means that 7 square is equal to 49, 24 square is equal to 576, 25 square is equal to 625. So we see that 7 square plus 24 square is equal to 25 square, because 7 square is 49, 24 square is 576 and 25 square is 625. Therefore the given triangle is a right angle triangle and the hypotenuse is 25 centimeters and the two legs are 7 and 24. Going to the second one, again you're having a whether we have to check whether it is a right angle triangle or not. So the bigger side we are taking it as 8, the other two legs are 6 and 3. So here you can see that 3 square is equal to 9 and 8 square is equal to 64 and 6 square is equal to 36. So now here we have to take the sum of squares of the two shorter sides, that is 3 square plus 6 square is equal to 8 square or not, we have to check. But here we can see that 9 plus 36 is not equal to 64. Therefore the given triangle is not a right angle triangle. Then going into third problem, here also we have to check given three sides. We are taking the largest side as 100 and we have to check whether 80 square plus 50 square is equal to 100 square or not. So therefore here 50 square is 2500, 80 square is 6400, 100 square is 10,000. So you can see that definitely here 2500 plus 6400 is not equal to 10,000. So therefore the given values, it doesn't form a right angle triangle. Next, going to the fourth one, we are given 13 centimeters, 12 centimeters and 5 centimeters. Here the largest side is 13 centimeters. So 13 square should be equal to 12 square plus 5 square. Yeah, we can see that it is equal because 5 square is 25, 12 square is 144 and 5 square is 13 square is equal to 169. So 25 plus 144 is equal to 169, which is nothing but 13 square. So the given triangle is a right angle triangle and the hypotenuse is nothing but 13 centimeters. Now going to the second problem, PQR is a triangle right angled at P and M is a point on QR such that PM is perpendicular to QR. Show that PM square is equal to QM into MR. So it is right angled at this point, means we are having this QPR, angle QPR is equal to 90 degrees, and also when PM is drawn as a perpendicular to the base QR, you are also having PMQ is equal to 90 degrees and PMR is also equal to 90 degrees. So what we are given, we'll just see here. Triangle PQR is right angle at P. This is the first one. M is a point on QR such that PM is perpendicular to QR. So we also have that PM square is equal to QM into MR. We have to prove this. So what we have to prove is, we have to prove that PM square is equal to QM into MR. So the proof part, if you are considering the triangle PQM by Pythagoras theorem, you can see here PQM, you can see from Pythagoras theorem that PQ square is equal to PM square plus QM square. So therefore which is equal to, or you can write it as PM square, we are writing in terms of PM. PM square is equal to PQ square minus QM square. That is, here subtracting QM square on both sides. So in triangle PMR, Again the next triangle will take, that is this triangle PMR. You can see from this triangle that PR square is equal to PM square plus MR square. So, or you can write it as, if you are subtracting MR square on both sides, then you get it as PM square is equal to PR square minus MR square. Now adding 1 and 2, we get that, so you are adding PM square plus PM square, it is 2PM square, and PQ square minus QM square, here you are having it as, it is written as, if you add this first and the second equation, you get it as PQ square plus PR square minus QM square plus MR square. Since QR square is equal to PQ square plus PR square, that means this is equal to QR square. You can see from the bigger triangle, that is from this bigger triangle, you can see that PQ square is equal to QR square is equal to PQ square plus PR square, because it is right angled at P. So therefore here you are having, it is written as QR square minus QM square plus MR square, and this QR square can also be, it is nothing but QR square is QM plus MR. Since you have seen that PM is the perpendicular bisector of QR, therefore it divides that into two equal parts, so QM plus MR. So therefore you can write it as QM plus MR whole square minus QM square. I am taking this minus sign inside, so you are getting this minus QM square minus MR square. So what is QM plus MR whole square? It's equal to QM square plus MR square plus 2QM into MR minus QM square minus MR square. You are expanding this using A plus B whole square formula that I have written here. So you are going to cancel out whatever is the negative and positive here. The remaining is 2QM into MR. Therefore 2PM is M square is equal to 2QM into MR. Hence we use the Pythagoras theorem for this, because both are right angle triangle and there is a perpendicular drawn onto the base which is also forms a right angle triangle. From that we have used that and we have proved it. Now third one, in the given figure ABD, triangle ABD is a triangle right angled at A and AC is perpendicular to BD. Show that AB square is equal to BC into BD. BC into BD, and AD square is equal to BD into CD. So we have to show this part here. So how do we do this? We'll see. Now ABD, we are given that ABD is a right angled triangle, right angled triangle at A, and AC is perpendicular to BD. Now we have to prove this three parts which we have already seen what we had to prove. So we'll take the first one to prove that. How to prove the first part we'll see. Now in triangle ADB, now I have drawn the triangle once again. Here you can see that ADB is a bigger triangle, that is considering the whole part, and CAB is only this part of the triangle, and then we are considering the whole bigger one, that is the whole outside, that is BDA or ADB. This is a triangle we are considering, and the next, this one CAB. So in these two triangles what we can see is, we can see that angle DAB is equal to angle ACB, which are equal to 90 degrees. Because it's 90, it is a right angle at A, you can see that angle DAB is definitely equal to angle ACB, because AC is a perpendicular onto BD. So they both are equal to 90 degrees. Next you can see that angle ABD. ABD is this part, and CBA. Both are equal, because in both the triangles we are taking ABD, B is there in both the triangles common. Therefore we are taking ABD is equal to CBD, which are common angles. So from AA common similarity criteria, you can tell that triangle ADB is similar to triangle CAB. So now if you consider here, if you consider AB by CB is equal to BD by AB. So you can see here AB square, if you cross multiply you will get AB square is equal to CB into BD. Because how are we getting this is because corresponding sides of two similar triangles are proportional. Corresponding sides of two similar triangles are proportional. You can write here corresponding sides of two similar triangles are proportional. Next, in right triangle, now we have to do the second part. In right triangle ACB and DCA, ACB, this part, this triangle, and next one, the other one is DCA, it's this triangle. In both C is only in between, so we are reading it as ACB and DCA. So now angle ACB is equal to angle DCA is equal to 90 degrees. And also we have that angle BAC is equal to angle ADC. How did we prove that this angle 2 is equal to angle 4 here? We can see from here. Since angle 1 plus angle 2 is equal to 90, because here you are given BCA is 90, isn't it? Therefore, the other two sides definitely, because the sum of this angle plus angle 1 plus angle 2 should be equal to 180 degrees. So we are having, since this angle, this dot angle is nothing but it's equal to 90 degrees. Therefore, angle 1 plus angle 2 should be equal to 90 degrees. Which is equal to, in the similar manner, we can tell that it's equal to angle 3 plus angle 4, which is also 90 degrees. So, but we know that angle 2 plus angle 3 is equal to 90 because it is a right angle triangle. It is right angle at A. So, therefore, angle 2 plus angle 3 is equal to 90 degrees. Now, equate angle this one with this angle 2 equal to angle 3. You can get 2 to cancel, angle 1 plus angle 3. Here you can get the time. Here you will get it as angle 1 is equal to. It is equal to angle 3. And again you are having angle 2 plus angle 3 is equal to angle 3 plus angle 4. Angle 3 will get cancelled on both sides. Therefore, angle 2 is equal to angle 4. That is what I have written here. Therefore, triangle ACB is similar to triangle DCA. Now, since these two triangles are using AA similar criteria, you can take the corresponding parts of this. That is, the corresponding sides of two similar triangles are proportional. Therefore, the corresponding sides which I am taking is AC by DC, this one, this part and this part, is equal to BC by AC or CB by CA. Then I have reversed it in the next step. Taken AC by DC is equal to BC I have written as CB I have written as BC, CA I have written as AC. So, therefore, you are getting this equal to AC into AC is AC square, which is equal to BC into DC. Since corresponding sides of two similar triangles are proportional, therefore, AC square is equal to BC into DC. Now, next third one. In right triangle ADB, here you get, and triangle CDA, you can see that here also again angle DAB, because both have this angle here DAB and angle DCA. You can see here this blue color part, whatever two angles I have marked, those two are equal to 90 degrees. And also you have that D is common for both the triangles. Therefore, angle BDA is equal to angle ADC. It's common. Therefore, from AA similarity criteria, you can tell, or similar condition, you can tell that triangle ADB is similar to triangle CDA. Now, if you consider the corresponding sides over here, you are having AD by CD is equal to BD by AD. Since corresponding sides of two similar triangles are proportional, now cross multiply, you are getting AD square is equal to BD into CD. Hence proved. Now going into the next one. ABC is an isosceles triangle, right angled at C. It's an isosceles triangle. Therefore, BC is equal to AC. Prove that AB square is equal to 2AC square. So now here you can see it's very obvious here. Because it's a right angle triangle, you have AB square is equal to AC square plus BC square. It is the square of the hypotenuse is equal to sum of squares of the other two sides. which implies that AB square is equal to AC square plus AC square. Why? Because BC is equal to AC. So therefore you are getting it as 2AC square implies AB square is equal to 2AC square, hence proved. The fifth one. Now triangle ABC is an isosceles triangle with AC equal to BC. If AB square is equal to 2AC square, prove that triangle ABC is a right angle triangle. It is the reverse of the previous one. So how do we do this? We'll see. Given an isosceles triangle ABC with AC equal to BC and AB square is equal to 2AC square. So triangle ABC is a right angle. To prove, we have to prove that ABC is a right angle triangle. Now proof AB square is equal to AC square is given to us. AB square is equal to, in the place of AC you can write it as this 2AC, you can write it as AC square plus AC square, isn't it? Now one of the AC you write it as BC because AC is also equal to BC. Therefore AC square plus BC square, AB square is equal to AC square plus BC square. It is nothing but the hypotenuse square is equal to sum of squares of the other two sides, which implies that triangle ABC is a right angle triangle, right angle at C. Now sixth one. ABC is an equilateral triangle. Triangle ABC is an equilateral triangle of side 2A. Find each of its altitudes. So what are its altitudes? We'll see. So what is given over here? For us given triangle ABC is an equilateral triangle in which AB is equal to BC is equal to CA is equal to 2A. It is also given that AD is perpendicular to BC, B is perpendicular to AC, CF is perpendicular to AB. We have to find out what is the value, what is AD, BE and CF. So in right triangles ADB and ADC, ADB and ADC, hypotenuse AB is equal to AC is given. A is equal to AD. AD is also equal to AD. Therefore, you are having this common side. Therefore, triangle ADB is congruent to triangle ADC, using RHS congruent condition. Therefore, BD is equal to CD, CPCT, which is equal to half of BC. Since D is the midpoint of BC, which is equal to half into 2A, which is equal to A. In right angle triangle ADB, we have that using Pythagoras theorem, AD square plus BD square is equal to AB square, which implies AD square is equal to AB square minus BD square, which is equal to 2A square whole square minus A square, which is equal to 4A square minus A square is equal to 3A square. So which implies that AD is equal to root 3A, B is also equal to root 3A and CF is equal to root 3A. Seventh one, prove that the sum of the squares of the sides of a rhombus is equal to the sum of squares of the diagonals. So given ABCD is a rhombus in which AC and BD are diagonals which intersect each other at O. So now we have to prove that AB square plus BC square plus CD square plus DA square, which is the square of all the sides, is equal to AC square plus BD square, which is the square of its diagonals. So we know that the diagonals of a rhombus bisect each other at right angles. So now if we consider, this is the rhombus which you are having and these are the diagonals which you have considered, and we are naming it as A, B, C, D and O. A, B, C, D and O. So now here you can see that we know that the diagonals of a rhombus bisect each other at right angles, means angle AOB is equal to angle BOC is equal to angle COD is equal to angle DOA, which is equal to 90 degrees. So now in right angle triangle AOB, you have that AB square is equal to AO square plus OB square. We'll take this as the first equation using Pythagoras theorem because it is right angle at O, AOB. Next, in triangle BOC, right triangle, we have BC square is equal to OB square plus OC square. The second, we are using again Pythagoras theorem here. So in the again in COD, triangle COD, right angle triangle, we have CD square is equal to OC square plus OD square. Take this as third one using Pythagoras theorem. Then the last, we are having AOD's right triangle. We have AD square is equal to OD square plus OA square. This is the fourth one. Using Pythagoras theorem, we got this. Now adding equation 1, equation 2 and equation 3 and equation 4, we get AB square plus BC square plus CD square plus DA square. All the sides we are adding, so you're going to get it as OA square plus OB square plus OB square plus OC square plus OC square plus OD square plus OD square plus OA square. All are repeated twice. So you're getting here 2 OA square plus 2 OC square, 2 OA square plus OC square and 2 OD square plus 2 OB square. So that we have written here. You can see. Now you know that OA is equal to OC is equal to half of AC. So here you can see this here. OA is equal to OC is equal to half of AC because it bisects at each other, bisect each other. So therefore it divides it into equal halves. So here from here you are getting that OA is equal to OC is equal to half AC and also OB is equal to OD is equal to half BD. So now in the place of OC we are going to write it as OA and in the place of OD we are going to write it as OB. So now you get it as 4 OA square. When you are adding all of them, you are getting it as AB square plus BC square plus CD square plus DA square is equal to 4 OA square plus 4 OB square. So now OA square can be written as half AC from this above, which is written in the bracket. So you can see this is half AC whole square plus 4 into half BD whole square is equal to 4 into 1 by 4 AC square plus 4 into 1 by 4 BD square. So 4 will get cancelled. So what we have to prove here is hence AB square plus BC square plus CD square plus DA square is equal to AC square plus BD square. Now going into the 8th problem. In the given figure, O is a point in the interior of triangle ABC. OD is perpendicular to, this is OD. OD is perpendicular to BC. OE is perpendicular to AC. OF is perpendicular to AB. We have to show that OA square plus OB square plus OC square minus OD square minus OE square minus OF square is equal to AF square plus BD square plus CE square. And the second part we have to prove that AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. So now solution. In triangle ABC, in which OD is perpendicular to BC, OE is perpendicular to AC, OF is perpendicular to AB, we have to prove this is already given. Now what we are doing is we are going to join O to B, O to C and O to A. So in right triangles OFA, in OFA we have OA square is equal to OF square plus AF square. This is the first equation by using Pythagorean theorem. Again in right triangle, so if we draw the figure here once again, you can understand it more well. So if this is the figure which you are having here, once again I am drawing it. You are having this is O, this is center point. From here if you are having all lines in this way, and these are all the perpendicular bisectors. So you can name this as ABC, A, B, C, D, F, D, E, F. So now this is O over here. It is a right angle triangle. So in right triangles OFA, we have OA square is equal to AF square plus OF square using Pythagoras theorem. In right triangle OBD, we have that OB square is equal to OD square plus BD square. Using Pythagoras theorem, in right triangle OEC, we have OC square is equal to OE square plus CE square. So by using Pythagoras theorem, now adding all these three, we get OA square plus OB square plus OC square is equal to AF square plus OF square plus OD square plus BD square plus OE square plus CE square. So now you take all these AF square, BD square and CE square, write all of them together, and OF square, OD square and OE square together. Now we are having, bring all of them to the other side, keeping this to the side, to one side, and taking the others to the other side. You get AF square plus BD square plus CE square is equal to OA square plus OB square plus OC square minus OD square minus OF square minus OA square, hence proved. We can rewrite the above proved result as follows. So this above result, whatever we having here, we have got it as AF square plus BD square plus CE square is equal to AF square can be written as, from this Pythagoras theorem, from here itself you can see AF square can be written as OA square minus OF square, and here BD square can be written as OB square minus OD square, and here CE square is written as OC square minus OE square. So we are going to write it in that way. So all those we are after writing. Now OA square minus OE square, if you bring together different terms together, you are going to get it as OA square minus OA square minus OE square. If you write, it is nothing but it's equal to AE square, OB square minus OF square and OC square minus OD square. You are going to get it as AE square plus CD square plus DF square. The same thing which we are writing in this way. So you are going to get the answer. Hence AF square plus BD square plus CE square is equal to AE square plus CD square plus BF square. So ninth one, a ladder 10 meters long reaches a window 8 meters above the ground. Find the distance of the foot of the ladder from the base of the wall. Now we have to use Pythagoras theorem for this. So now AC is the ladder here and C is the foot of the ladder, such that AC is equal to 10 meters. A is the position of the window and AB is the wall. So now in right triangle you can see that AC square is equal to AB square plus BC square using Pythagoras theorem, and we have to find out what is BC. So BC square is equal to AC square minus AB square, that is 10 square minus 8 square, which is equal to 100 minus 64, that is 36. So BC is equal to 6 meters. Hence the distance of the foot of the ladder from the base of the wall is 6 meters. Now 10th problem. A guy wire attached to a vertical pole of height 18 meters is 24 meters long and has a stake attached to the other end. How far from the base of the pole should the stake be driven so that the wire will be taut? So now in this problem we have that it will be, in right triangle ABC we have AC square is equal to AB square plus BC square. It's obvious because we are using our triangle. Here you can see this is the wire. It is tied to a vertical pole and this pole is 18 meters and this wire is 24 meters long. We have to find out how long from the base, how far from the base of the pole should the stake be driven so that the wire will be taut. Means the wire will be tight over there so that we can tie it from this pole. So that what is BC we have to find out. So 24 square is equal to 18 square plus BC square. Find out what is BC. It is nothing but equal to 576 equal to 324 plus BC square. This is plus. So which is equal, which implies BC square is equal to 576 minus 324, which is equal to root of 252. BC is equal to 6 root 7 meters. Hence the stake should be driven 6 root 7 meters from the base of the pole so that the wire will be taut. Now 11th one. An aeroplane leaves an airport and flies due north at a speed of 1000 kilometers per hour. At the same time, another aeroplane leaves the same airport and flies due west at a speed of 1200 kilometers per hour. How far apart will be the two planes after 1.5 hours? So now here we have a distance of the aeroplane leaving the airport and flying due north at a speed of 1000 kilometers per hour after 1.5 hours is equal to OA, which is equal to 1000 into 1.5 hour kilometers, that is equal to 1500 kilometers. So distance of the aeroplane leaving the airport and flying due west at a speed of 1200 kilometers after 1.5 hours is equal to OB, which is equal to 1200 into 1.5, which is equal to 1800 kilometers. So in right triangle AOB, we have to find out what is AB. So in order to find out AB, we use the Pythagoras theorem. AB square is equal to OA square plus OB square, which is equal to AB square is equal to 1500 whole square plus 1800 whole square, that is equal to 220. Here you can see the value of here 1500 square and 1800 square over here. 15 square is 325, add 4 zeros. 18 square is 324, add 4 zeros. So AB square is equal to, add 324 and 225, you're getting 549. So you're getting the answer as root of 61 into 9000, which is 300 root 61 kilometers. Hence the two planes will be at a distance of 300 root 61 kilometers apart after 1.5 hours. Now next 12th one. Two poles of height 6 meters and one more is of 11 meters stand on a plain ground. The distance between the feet of the poles is 12 centimeters. Find the distance between their tops. So now here you can see from the figure obvious that this one pole is 6 meters and the other pole is 11 meters. You can draw a line parallel to the base, which is AB. The distance between the two poles is 12 meters. So therefore you can see over here the distance between BC and AD is equal because they both are parallel. So this is 6, means 11 minus 6 will give you 5 meters. Now here you can see that DCE forms a right angle triangle. So we can find out what is D, the distance of their height of the poles. So here AD and BE are two poles of height 6 meters and 11 meters respectively. D and E are the tops respectively. A and B are the feet respectively, such that AB is equal to 12 meters. So to prove what is DE, so draw DC perpendicular to BE, or you can also draw parallel to AB. So join here you can get, and also join DE. So ABCD is a rectangle and BC and AD are its opposite sides. Therefore BC is equal to AD. Since opposite sides of rectangle are equal, it is equal to 6 centimeters. We have 6 meters. We have seen it from the figure. And therefore here you are having DC is equal to AB is equal to 12 meters. C is equal to D minus BC, that is 11 minus 6, which is equal to 5 meters. So by using right Pythagoras theorem for the right angle triangle DC, we get DE square is equal to DC square plus CE square by Pythagoras theorem, which is nothing but it's equal to 12 square plus y square, that is you're getting it as 169. So DE is equal to root of 169, which is 13 meters. Hence the distance between their tops is 13 meters. Next, D and E are points on the sides CA and CB respectively of a triangle ABC, right angle at C. Prove that AE square plus BD square is equal to AB square plus DE square. We have to prove this. So in a right triangle ABC, right angle at C, D and E are points on sides AC and BC respectively. We have to prove that AE square plus BD square is equal to AB square plus DE square. So using Pythagoras theorem for the first one, that is triangle ABCD, because it's right angle at C, we can write it as BD square is equal to BC square plus CD square. Then adding 1 and 2 here, we get here in the proof part, in triangle AEC, using Pythagoras theorem, we have that AE square is equal to EC square plus AC square. Take this as equation 1. This is what we have to prove. So therefore, to prove AE square plus BD square is equal to AB square plus DE square, in triangle AEC, using Pythagoras theorem, we have A square, because it's a right angle triangle, AE square is equal to EC square plus AC square. And next, in triangle BDC, it's also right angle triangle, we have BD square is equal to CD square plus BC square. So take this as the first equation, this as the second equation. Adding 1 and 2, we get AE square plus BD square is equal to AC square plus BC square plus CE square plus CD square. So which implies that AE square plus BD square is equal to AC square plus BC square. AC square plus BC square is nothing but AB square, and CE square plus CD square is nothing but DE square. So that is, it is proved. That's why it's equal to AB square plus DE square. Now 14th, the perpendicular from A on side BC of a triangle ABC intersects BC at D such that BD is equal to 3CD. Prove that 2AB square is equal to 2AC square plus BC square. So now here, given a triangle ABC in which AD is perpendicular to BC and DB is equal to 3CD, we have to prove that 2AB square is equal to 2AC square plus BC square. Now proof over here, DB is equal to, since DB is equal to 3CD, you can write this as, now BC is equal to CD plus DB. So therefore, BC is equal to CD plus DB. In the place of DB, we are writing it as 3CD. So you are getting BC is equal to 4CD, or CD is equal to 1 by 4 BC. So in right triangle ADB, you can tell that AB square is equal to BD square plus AD square by using Pythagoras theorem. AB square is equal to AD square plus DB can be written as BC minus CD. BC minus CD. So which implies that AB square is equal to AD square plus, here you have to use A minus B whole square. So BC square plus CD square minus 2BC into CD. So which implies that AB square is equal to AD square plus CD square. These two together we are writing. Then plus BC square minus 2BC into CD. So now here you are having AC square plus BC square minus 2BC into 1 by 4 BC. So now in right triangle ADB, we have AB square is equal to AD square plus DB square. Using Pythagoras theorem, we know that AB square is equal to AD square plus, now DB square over here, from here you can see that it is equal to 3CD, or it is also equal to dB is equal to BC minus CD. Here you can see from here BD is equal to BC minus this part CD. So we are writing that here BC minus CD. So AB square is equal to AD square plus, you are expanding this by using A minus B whole square property. So it is A square, that is B square, BC square plus CD square minus 2BC into CD. So which implies that AB square is equal to AD square plus CD square, we are clubbing this and this, plus BC square minus 2BC into CD. So now which implies AB square is equal to AC square plus BC square minus 2BC into 1 by 4 into BC. Now you know that AD plus CD, AD square plus CD square is nothing but it is equal to AD square plus CD square is equal to AC square from the triangle. You are having this triangle ADC. From this, because this is a right angle triangle, you can see that AC square is equal to AD square plus CD square. So in this place we have written it as AC square plus BC square minus 2BC into CD is written as 1 by 4 BC. We have proved it before. So now you can take this as AB square is equal to AC square plus BC square minus BC square by 2. So which implies that AB square is equal to 2AC square plus taking LCM plus 2BC square minus BC square by 2, which implies that AB square is equal to 2AC square plus BC square by 2. So now cross multiply, 2AB square is equal to 2AC square plus BC square. So that's the answer. Now next, going into the 15th one, in an equilateral triangle ABC, D is a point on the side BC such that BD is equal to 1 by 3 of BC. Prove that 9AD square is equal to 7AB square. So now here you are having an equilateral triangle ABC such that BD is equal to 1 by 3 of BC. So now you have to prove that 9AD square is equal to 7AB square. Now draw AE perpendicular to BC. In right triangle ABE and AE is perpendicular to BC. So now in right triangle ABE, like you are having a triangle in this way, A, B, C, here you have drawn this is AD, this is equal to BD is equal to 1/3 of BC, and this is perpendicular to AE is perpendicular to BC. So now in this triangle ABE and ACE, these two right triangles, you are having AE is equal to AE common, AEB is equal to AEC, that is 90 degrees, and AB is equal to AC because triangle ABC is an equilateral triangle. Therefore, by using Rhs Congruence Criterion, you can tell that triangle AB is congruent to ACA, which implies that B is equal to CA. So by CPCT, that is corresponding parts of congruent triangles, which implies that B is also equal to CA, that is equal to half of BC. So in triangle ADE, we have that AD square is equal to AE square plus DE square, which implies that AD square is equal to AE square plus, now here again if you draw the triangle here, you can see that A, B, C, this is AD, and if you bring a line this way, this is AE. You can see from this that AD is equal to AE square plus what is D? D is equal to nothing but to B minus D. If you are taking this part, this whole part, B minus of BD. So we are taking this, it's equal to B minus BD whole square, which implies that AD square is equal to AE square plus BE square plus, expand this B minus BD whole square in the formula using A minus B whole square, you are getting B square plus BD square minus 2BD into BE. So which implies that AD square is equal to AE square plus BE square plus BD square minus 2BD square into BE. We have taken this together. Now AE square plus BE square, you know that BD is equal to 1 by 3 of BC and B is equal, C is equal to half of BC. So substituting those in this, we get that AD square is equal to AB square C square plus B square A square plus B square is nothing but it's equal to AB square. That only we have written here from the Pythagoras theorem. This is equal to AB square, that we have written here, plus BD is equal to 1 by 3, here it is given 1 by 3 BC whole square minus 2 into 1 by 3 BC into half BC. So which is equal to, you are going to get it as AD square is equal to AB square plus 1 by 9 BC square minus BC square by 2 will get cancelled, by 3 you are getting. So if you take LCM on the right hand side, you are getting it as 9AB square plus BC square minus 3BC square by 9. So taking 9 to the other side, you are getting 9AD square is equal to 9AB square minus 2BC square. Since we know that AB is written as BC minus CA, so 9AD square is equal to 9AB square minus 2AB square. You know that all these sides are equal, isn't it? So you are having AB is equal to BC is equal to CA. It is an equilateral triangle. Therefore 9AB square minus 2 BC is equal to AB. So you are writing BC as AB. So it's equal to minus 2 AB square. So therefore 9AD square is equal to 7AB square, hence proved. Next, 16th one. In an equilateral triangle, prove that 3 times the square of one side is equal to 4 times the square of one of its altitudes. So now in the solution, this is given ABC is a triangle, AD is the altitude. So equilateral triangle ABC in which AD is an altitude drawn to the side BC. You having also AB is equal to BC is equal to AC. You have to prove that 3 times AB square is equal to 4 times its altitude square. That is AB is equal to AC. Triangle is equilateral. When AB is equal to AC, you having angle B is equal to angle C, which is equal to 60 degrees common, and angle ADB is equal to ADC, which is equal to 90 degrees. So by using Rhs congruent condition, triangle ABD is congruent to triangle ACD. So now we can use, implies that BD is equal to DC. So which implies that BD is equal to DC is equal to half of BC, half of the whole thing. So now in right triangle ABD, right triangle, we have that. See, you can draw the figure here once again. It is so that you can have a clear picture of it. This is A, B, C. This is an altitude AD. So in ABD right triangle, we have that AB square is equal to BD square plus AD square, or AD square plus BD square. And we have just now proved that BD is equal to half of BC. So you substitute that AB square is equal to AD square plus 1 by 4 BC square. Taking LCM, you are getting AB square is equal to 4 AD square plus BC square by 4, which implies that 4 AB square is equal to 4 AD square plus BC square. So which implies 4 AB square minus BC square. Subtract minus BC square on both sides. So you are getting minus BC square, which is equal to 4 AD square. So which implies 4 AB square minus AB square, because BC is equal to AC, isn't it? All are equal, which is equal to 4 AD square. So 4 AB square minus AB square is nothing but 3 AB square, which is equal to 4 AD square. Now next, pick the correct answer and justify. In triangle ABC, AB is equal to 6 root 3, AC is equal to 12 centimeters and BC is equal to 6 centimeters. Then angle B is equal to how much we have to see. Now here he is telling that we have to see here AB square is equal to 6 root 3 whole square, which is 108. AC square is equal to 12 square, which is 144. And BC square is equal to 6 square, which is equal to 36. So now AB square plus BC square, the smaller sides will take 108 plus 36, you are getting 144, which is AC square. Therefore triangle ABC is a right angle triangle. So right answer is nothing but it is B. The correct answer is C, which is equal to 90.